Now, there are some kinds of advanced questions that don't tend to be answered in modern commercial systems, but are part of modern research systems, and let's turn to those now. Imagine the following harder question: what is water spinach? And the answer we'd like to give is really a full paragraph that talks about water spinach and its history and names for it in different languages and so on. So we'd like to be able to build that kind of question not by just looking it up on the web, but by merging together possible snippets we might get from different sources. Or we might get hard medical questions like, in children with an acute illness, what's the efficacy of a particular medicine? And an answer there might be, again, a summary of things we might see from a particular PubMed paper. We might want to read a sentence and decide, read a document and extract sentences, and we can say where they came from and how much we believe them. So these are the kind of harder things that are important in the research literature, but haven't yet made it into modern commercial systems. And for answering these harder questions, we often use an approach that's called query-focused summarization. And query-focused summarization means that we're applying a natural language summarization algorithm. We're going to summarize multiple documents, pull information from multiple documents, but it's query-focused. It's not just a summary of everything that's in those documents. It's the parts that are relevant for a query. And there are two kinds of algorithms for query-focused summarization. One of them, what we might call the bottom-up snippet method, we find a set of relevant documents, extract information from them bottom-up using TF-IDF, deciding how many sentences are relevant by their TF-IDF score, other kinds of scores, and then we combine and modify the sentences into an answer. And what I'm going to talk about today is a second method, which we might think of as an information extraction method. And here we build specific answers that work for different question types. So we might have definition questions or biography questions or certain medical questions. And for each of those, we might decide what constitutes a good definition question or a good biography question or a good medical question. And we're going to build specific answers for those. So, for example, we know that a good biography contains a person's birth and death, dates, it contains how famous they are, what they're famous for, their education, their nationality, and these kind of things. Whereas a good definition contains what's often called a genus or hypernym. So we know what is a Hajj? It's a type of ritual. And a good medical answer contains the problem that the medicine is designed to solve, the intervention, what is this drug or intervention we're going to use, and then the outcome, the result of the study describing this problem. So for these three kinds of answers, we might know that we need to extract, for a definition question, we've got to build a genus detector and a species extractor, a subtype extractor, whereas for a biography question, we need to build a date extractor and a nationality extractor, while for a drug efficacy question, we have to extract the population a study was run on, or what the problem or intervention are, and so on. And I've given you examples here of the kind of sentences we need to extract for these kind of answers. So here's a sample architecture for a complex question answering system from Blair Goldenson et al. Here you might have a question like, what is the Hajj? And we might specify that we'd like to search 20 documents and extract an answer of about 8 sentences. So we'll do document retrieval, pull lots of relevant documents, and now we're going to build classifiers whose job is to pull out genus species sentences. So the Hajj is a pilgrimage, the Hajj is a milestone, the Hajj is a pillar, and so on. And a classifier that pulls out other non kinds of definitional sentences. And we're going to cluster these and order these and produce as the response an answer of about 8 sentences that summarizes a good response to the question. So advanced question answering algorithms used in the laboratory either use information extraction methods or use bottom-up clustering methods to combine information from lots of documents to create a set of sentences that answer a question. But more commonly, commercial systems are based on factoid answers. So either using knowledge bases or more often using information retrieval techniques to find sentences that contain an answer to the question, extracting and ranking the answer, and then presenting it to the user.